Good afternoon, students, and welcome to this webinar on machine learning with Python. I happily invite and thank Ms. Durga, for joining with us and be ready to take the session with the insight of machine learning with Python, having a Python library suitable for machine learning and machine learning in artificial intelligence, and with an overview of machine learning applications. Ms. Durga has around 3 years work experience in embedded software development in 3Q technologies. Some of the projects which she has worked in as IoT-based remote monitoring of solar panels using Raspberry Pi and Modbus protocol, and also a napkin vending machine using PIC 16F877A. I'm so happy to have you here, and the thanks goes to Carrier Vision company, which has also organized this webinar. Thank you, and over to you. Durga, you can take over.
Thank you, ma'am. Thank you so much. So I'm currently sharing my screen. Please let me know if it's visible.
Yes, please.
So is it visible, ma'am, my screen?
Yes, it's visible.
Okay, ma'am. Thank you. So good afternoon to everyone present here. In this webinar today, we're going to see about machine learning with Python. So to begin with, let me quickly tell you the overview of today's webinar. So first, we're going to see what is Python, the overview of Python, and the usages of Python in real world is nothing but the applications of Python. And then we'll move on to machine learning. We'll see what machine learning is and the applications of machine learning and how machine learning plays an important role in artificial intelligence, followed by a quick demo of Python code that implements machine learning algorithm. So if you have any doubts, please post your questions in the comment section. So after I complete the webinar, I'll go through the session and go through the chats and clear your doubts. And in case if you have any pressing doubt that needs to be answered immediately, you can switch on your mic and then question me. As I'm presenting the screen, I will not be able to see your chats. So please do understand that. And if the doubt is not so pressing, you can give it in the comment box. I hope I made myself clear. Okay. So let us move to the webinar. And first, as I said earlier, we'll see what Python is. And to tell about Python, it is a high-level programming language, meaning the language has more keywords that are related to English and that can be easily understood by humans than it is more related to that of the machine. And we already know machine understands only ones and zeros. So Python is a high-level programming language which is user-friendly and makes the user learn it in a quick manner. And it was developed by Guido van Rossum and released. He started this development in 1989, and it was officially released in 1991. He's from Netherlands. So a company called CWI at Netherlands had a sort of government-aided company, and their motto was to develop a programming language that used to help in that is very similar to that of the C language, and it's used to aid in developing operating systems. So what they initially came up or developed was an ABC language, a language that was named ABC. And this language had a few defects, such as it looked exactly like a shell script, meaning it looked it wasn't user-friendly, and it took a lot of time to read and understand what the code is. And it was very similar to that of the command script. So, and also it was not as, it did not achieve the expected results. Hence, they proceeded to develop another language from this ABC. So rectifying the disadvantages of ABC, and that is when they developed Python. So Python was developed by Geordo von Rossum, and this Python language, overcame the disadvantages of ABC language, and it is a high-level programming language, and it's very easily interpretable, and it is easy to learn by users. So widely, most commonly, Python is used for web development, software development, and in places where mathematical algorithms need testing or running or development, and in system scripting. Moving on to features of Python. These are a few features or the widely known reasons for why Python is preferred. We'll go through them one by one. So the first is simplicity. Here we have two snippets of code where Python is compared with Java and Python is compared with C++. Generally, in C++ or in C, we will know that we'll have to include header files and then write code in a main function and then execute it. All of this function, these snippets of code, the function in which they achieve is achieved in this one line of Python code. So you can see how the lines of code is reduced, and also it is simple for the beginner or the learner to understand what is being done in this Python script. Similarly, when we consider Java, we have to create a class and then create an instance of that class and then use it. Whereas in Python, we can just use the syntax, which is easy to read and understand, and also learn from the beginning. So simplicity, this is one major factor for which Python became most sought after language, and this is why it is being used widely. One reason is because of its simplicity. Moving on, the other 2 points are open source and portability. So open source is nothing but this language is available free for everyone worldwide. As soon as it was released in 1991, this became open source. Everyone had access to this Python language, and they could develop codes or libraries or snippets of their own and use. One major advantage is that it's open source and portability. So it is not operating system dependent. It is not OS dependent. And this Python code can be shared in the same way in which it was intended to do. This is one of their the goals for developing another language similar to that of the C, in which they needed that language to be portable. They needed that language to work in Windows, Linux, Mac, .NET, and any other operating system. They needed this language to work with hassle-free, without any much transfers or complicated steps performed. And this Python achieved that. Hence, this portability is another major boon or advantage for which we prefer this. Next, huge amount of libraries. Let us first understand what data science is. So data science is nothing but having huge amounts of data. That data can be it can be of your employee record or something. So that you have a large amount of data with you, and you need to perform certain operations on these data and extract information. For example, to see you have an employee record, and to see who are all the employee who stay and work overtime. So what we'll have to do is we'll have to check in with their login time and then get data as to who is working overtime, and have to perform this operation and filter and get the data, extract that information. So in data science, what we generally do, or how we can say it in simple man terms, is that we have a huge, large amount of data. We perform certain operations and extract information from it. To perform this process or to manage a large number of data, it is difficult in certain languages. Whereas in Python, it is very easy to handle this data using libraries such as pandas and numpy to extract information. Not only we can perform operations and extract the required data from it, also we can use certain libraries such as matplotlib and seaborn to visualize such data, to see how the variation of data is regarding, we can view it as graph, we can view it as pie charts, and the visual representation also will help us understand the nature of the data or change in the data. So this is what data science is, and Python plays a very huge role in supplying these libraries. So all these functions which we want to work with this data are inbuilt and given in this libraries. We just have to import that libraries, like how we include header files in our C program and execute. Just like that, we have to import these libraries and then use the functions in that libraries to perform our job. So this is how Python eases the a huge bump in which we'll have to process data that is present in data science. So these are all the major features or the reasons for which we use Python and how it eases our real-time problem-solving techniques. Moving on to the places where Python is used or the applications of Python. First and foremost, Python is widely used for machine learning. So we'll be seeing what machine learning is in the later part of the webinar. For now, let us just remember that machine learning is nothing but another aspect or a learning of Python, where machine learning is giving a huge amount of data to your machine or model and training that model. So training that model with regards to your data, and then reviewing or getting the output out of that model in which you have trained. So machine learning is nothing but you're training a model with data and using it for your future predictions, future value predictions. So this is what machine learning does. So to achieve the machine learning, we have certain algorithms that are established and widely used. And Python has inbuilt libraries for these widely used algorithms. Hence, Python provides a major or a wide resource with which we can work in machine learning. Another important application of Python is web scraping. So web scraping is nothing but, say you have a website. So if you want to download or view the data from in which the website, view the data in the website, like from which server the website works, or from which server the data is being uploaded, what kind of code they have written, we'll access the HTML code, underlying HTML code, and with that we'll access the database in which all these data are stored. This is known as web scraping. For this web scraping, Python is used. So one pretty big example of web scraping is, say you have a Facebook account, and then you download images or save videos from your Facebook account. That is possible because of web scraping. Another widely used application is stock market, where we download data from the stock market's database using this web scraping. For this web scraping technique, Python language is used to code and download the data from their database or server. Moving on to game development. So Python has libraries such as PySoy and Python 3, Pygame, where in Python 3 we have a Pygame library, where these libraries are used to develop the code for certain games. These games are mainly like reward games, in which, say, if you have used MPL or saw ads in which they'll play this game, win, and certain money will be credited in your wallet. So games like those reward games use Python libraries for their development. Python is mainly used to develop the code in the back end and not front end. So difference between back end and front end is that front end is something which you see on your screen. This is your front end. So this is what you see on screen, in which you interact with your application, is what we call as front end. And the backend is nothing but the supporting code which makes this front end possible. So this is backend. So Python is used in the backend and not in the front end because it doesn't have the aesthetic appeal. And it supports a few games in which the development seems to take only less time. And those games are example for those games are reward games, and where in your Paytm or any other apps, it will be like, play this game, get 1 rupee reward, get 10 rupees reward. So for those games, Python is used in the backend development. So for those, the libraries which they use are PySaw and Pygame. This is how Python aids in game development. Then comes the audio and video applications, where the players in which you use to play your audio or video, such as StimPlayer or CPlay, they are developed using Python libraries. So the difference between the normal players and the libraries which are developed using the Python players which are developed using the Python libraries are, these players, that is why we prefer them. And the main reason for them being this stable or giving a higher performance output is because they are developed using Python libraries. So this is how we can say Python even helps us in developing audio and video applications. So this is in general an overview about Python, the features of Python, and the applications or the real world usages of Python. Now let us move on to the second major part of this webinar, which is machine learning. So, introduction to machine learning. Okay, so what is machine learning is that it is a classification or a subset of AI. AI is nothing but artificial intelligence. So what machine learning is that, say you have a huge amount of data, and with this data, you have to train your system in a way that it should understand the pattern in which these data vary, and then must help you to predict values in the future. To relate machine learning to that of a real world example is that, say there is a kid who is less than 5 years old. You're trying to teach him or her a new thing. For example, we are trying to teach him to identify an apple. So say now I'm showing him one apple and telling him this is an apple. And after a week or so, if I ask him to, if I show another apple and ask him to identify it, the chances are less that he is able to identify that apple. So what should I do to improve his chances of identifying an apple is that I should show him several another slices or pieces of apple and make him understand that all of these represent one common commodity, which is apple. So that, say you are showing 10 apples now to him and telling all of these are apples. This is how you identify an apple, with its shape, size, the color, and this is how it feels. And later, after a week or so, now if you give an apple to him and ask him to identify, the chances of him identifying that apple is more. That is how machine learning works. If you give the more and large amount of data that in which you give the system to train, the better are your chances of it predicting the outcome correctly. So why do we now saw what machine learning is. So let us move on to see why do we need machine learning. The first point is increase in data generation. So the larger amount of data, if we have say about 50 to 100 data, it is easily possible for human beings to interpret them and predict what its values are going to be. And even then, we are not sure if our prediction is correct or not. What if we have data that has 1 lakh varieties in it? So increase in data generation is one major reason to why we need the machine to have to train itself for this data and predict accordingly. First point is increase in data generation. Next is to uncover patterns and trends in the data. So to see what, for example, let us take the apple example again. To see how an apple is being identified by its shape, by its color, by its texture, how the sunlight reflects from the apple. So to identify the pattern or the trends in the data, how this data stands unique from others, or how this data moves and what is the trend in this data, to uncover that pattern. So for that, we need machine learning. We need a machine to train on that data and understand what is the pattern in that data. Next, Next major point is to improve decision making. So improve decision making and solve complex problems. Both of these will come under artificial intelligence, where the machine learning part will be over in this. It will analyze the data and uncover the pattern in the data. In AI, what we do is that with the help of machine learning, we'll understand the pattern of the data, and with that we'll take decisions, improved decision making. So if there are critical conditions, so which should be given priority? If there is a fire, who should be saved first? Human beings or any other animal that is in the vicinity? First human beings and then the animals. That doesn't mean we shouldn't save animals. The priority, it matters. So improved decision making is one major part where AI plays a huge role. And then solving complex problems, not only taking decisions but also solving puzzles or problems with which we can use that particular solution to create say for example, if we are creating a cure for some disease. So we need, that is a complex problem. We need the data from the machine learning and decision making from the AI to solve that problem, and with that solution we can create a cure for that disease. So this is how AI and ML are needed in our day-to-day life, and these are the points, or this is how we apply them. So the next major question is, can a machine think or make decision? Okay, let us see how we can do that, if we can do that. So the answer is yes, the machine can think and make decisions. So the next question which pops is how. So if we feed the machine a large amount of data, and if we give algorithms for it to train on that data, the machine, what it will do is it will build a model which depends on the algorithm and the data which we have given to the machine. And with this model, model which is developed by the machine, we can use that model to predict the outcome of future events. For example, say I have a house, and this house has features like it has 2 bedrooms, it has 1 hall, a kitchen, this much square feet, it is located in the prime part of the city, and so on and so forth. So if we give these data to the machine and train the machine into an algorithm, so that train the machine with algorithm, so that what it does is that it will predict the value of this house in the future. I'm giving data for the past 20 years for the price of this house. So the data will vary depending on the number of bedrooms. So if I'm giving it for a 3 BHK, the price will obviously be higher, and if it's for a 2 BHK, it will obviously be lower. And depending on the square feet, the location, these are all the features or the aspects of the house which alter the price of the house. So I'm feeding the data for the last 20 years. So for the last 20 years, how the price of the house is being varied, I'm feeding it to the machine, and then I'm training it. So what the machine does is that it will build a model, and with this model, I can use that model to predict the price of my house in 2030. So I can use this model to predict my future outcomes. And this is how we are enabling the machines to think and make decisions. And we solve the real world problems. So I can predict what my house's price will be in the near vicinity or in the future. On to machine learning, we'll have to learn certain terminologies and understand their meaning. So first is algorithm. So what an algorithm is, that is nothing but a set of rules or a mathematical statistical formula for which we are with which we are analyzing and uncovering the patterns from the data. So the set of rules or algorithms, equations with which we analyze the data is called as an algorithm. Next, model. So what a model is that? We saw in the previous slide that the machine trains on certain algorithm and it builds a model. So this is what we call as a model. A model is nothing but a component of machine learning, and this algorithm will map with that of the data and will develop this model so that we can use this model to predict the future outcomes. Moving on to training data and testing data. This is nothing but training data is the data with which you train the system. Let us again move back to the example in which you show an apple to the kid. So the 10 apples with which you show and train the kid is called as training data. And the apple with which you ask him the question in the next week. So you show another apple and ask him, okay, tell me what this is. That is testing data. So you train your machine with certain data, and you test your machine with certain data. So this is the difference between training data and testing data. Ideally, what we do is that if we have large amount of data, we divide, say we have 1 lakh data, we take about 60% of the data to train our system and 40% of the data to test our system. So that with that testing itself, we can identify how accurate our system is to predicting what the outcome is. So this is how we generally do with machine learning. For now, let us just understand what training data and testing data is. What machine learning is, how we saw how machines think and the need for machine learning. Now let us see the types of machine learning. So generally or majorly, there are 3 types of machine learning. They are supervised, unsupervised, and reinforcement learning. Moving on to the first type, which is supervised learning. This is nothing but you give the data and the machine trains an algorithm and it gives you the output. So what difference is going to come in the supervised learning is that you label the data. You show a Tom and Jerry, you're like training the system to identify Tom and Jerry. So you show a picture of Tom and tell your system that this is Tom. And you show a picture of Jerry and tell your system that this is Jerry. The more variety of pictures you provide for the Tom and Jerry, the better results you will get. So imagine I'm showing these pictures to my system, labeling them as Tom and Jerry accordingly and giving it. So what the system machine learning does is that it takes an algorithm and trains on it. So this is the training phase. And finally, we'll develop a model. So with this model, what we are doing is that we are evaluating it or we are testing it. So what I'm doing is that I'm just giving a Jerry's picture and asking my system to predict or tell me if it is Jerry or Tom. And it tells me if it is Jerry, it is class Jerry, and if it's Tom, it tells me it's class Tom. So if I'm training my data with, if I'm training my system with data which is labeled, then it is called as supervised learning. Now, let us see what unsupervised learning is. Unsupervised learning is nothing but you are giving the system data, but you aren't telling the system what that data means. You aren't telling the system this is Jerry. No, you're not saying anything. You're just giving this set of data. The system again applies algorithm, solves and understands the pattern, and then it develops a model. With this model, you are evaluating. So if you give if you give a Jerry's picture, it will fall under this cluster. And if you give a Tom's picture, it will fall under this cluster. So what unsupervised learning is that it takes the unlabeled data. I'm not telling it is Jerry or Tom. And depending on the nature of the data. So there are only 2 types of data in here. So that is what we call as nature. And depending on the nature of the data, it clusters the output into 2. So since we have only 2 types of different data in here, it is clustering it into Jerry cluster and Tom cluster. So when you give a Jerry's picture, it will fall into this cluster, and a Tom's picture, it will fall into this cluster. This is what unsupervised learning is. This is you don't provide a guidance to your machine, you don't label the data, and it learns on itself and clusters the data. This is what unsupervised learning is. Moving on to the third type, which is reinforcement learning. This is quite different from the other 2 methods of learning, where you have, say, again, we take an apple in this example, and we have to find if it is an apple or not. So the output which we get is going to be yes or no. So we feed that apple, and the system identifies it as apple. Let us take the first scenario. There are 2 scenarios. We'll see both of those scenarios, and let us now consider the first scenario, in which the system identifies it as an apple. Yes, this is an apple, it is telling. So what I do is that I give a feedback to the system telling, yes, you're correct. I'm giving a positive feedback to my system telling that, yes, you have correctly identified that it is an apple. So what system is that? It takes those features and saves it into apples category. Okay, this is first scenario. Let us move on to the second scenario, where I am showing an apple to the system, but it doesn't recognize it as an apple and tells, no, this is not an apple. So what I do now is I give a feedback again, but this time it is a negative feedback. I tell them, no, it is an apple. You're telling it wrongly. So what the system is that it will see that it has been given a negative feedback, and then store these features in the apples column. So it is an apple, it has predicted, no, it is not an apple. So it has done a mistake there, and it will rectify that mistake. This is how reinforcement learning works. What it does is that based on the reward is nothing but the feedback which it gets, it will understand its environment, and its actions will reflect that reward in the future outcomes. So this is how reinforcement learning works. So these are the three types of learning in machine learning. Supervised, in which we give labeled data, and in which we observe the output which are labeled. In unsupervised learning, where the data is not labeled, we are not giving any guidance to the system. The output will be the clusters. Number of clusters will depend on the nature of the data. In this we have only two types of data, so we get two clusters. So this is unsupervised learning. And reinforcement learning is nothing but we give the system a feedback. It can either be positive or negative, and depending on the feedback, it learns, and its actions reflect those feedback in the future possible scenarios. This is reinforcement learning. So these are the major three types of learning in machine learning. So moving on to how machine learning is used in artificial intelligence is that, first let us see how AI is being classified. So these are the classifications of AI, and the first and foremost is machine learning. Machine learning plays a major or a wide part in AI, where we use ML to solve or analyze the data and uncover the patterns in it. So what are all the other classifications of AI are? NLP, natural language processing. So natural language processing is nothing but the technology in which we use Google Assistant. So if we ask our Google Assistant to set alarm, it sets alarm. You just speak to the Google Assistant and it automatically sets alarm. So this is possible because of natural language processing, where the system has to understand your accent, convert your speech into text, and then process that data. So if I'm telling set alarm for 7 a.m., what it does is that it listens to my voice, understands my accent, converts my words into my speech into text, and then processes on it. And later, what it does is that after setting the alarm, it tells me alarm is set for so and so. So that is nothing but conversion of text to voice. The Google Assistant replying to me is nothing but conversion of text to voice. This is how NLP, or natural language processing, works, and this technology is widely used nowadays, and this is another major part of AI. And under this comes speech, as I've explained in the process. Speech is required for the conversion of speech to text and text to speech. So this vice versa process is very much required to make NLP possible. Next is the expert systems, where you have a large database, and in which you want to solve certain problems or analyze the trends in those data, and using this database knowledge, you are solving some problems. You are applying it to a real-time problem and then getting solution. This is expert systems. And then planning, scheduling, and optimization. So this is one major feature where you have several solutions to one problem, and in which you will have to identify and use the solution which is more optimized and which gives better results when compared to that of the other solutions. So you'll have to plan accordingly, schedule, and then optimize your results so that you receive the highest benefit out of all of them. And then comes robotics, where robotics is a major division in which AI performs, in which we use AI to the fullest possible. What we do initially, we had robots that just assisted us. They were semi-automatic. You can tell that assisted us in certain operations. For example, you had robots in industries, manufacturing industries, or you had robots in restaurants where they just come and drop your food. So these robots were semi-automatic, in which you had to give commands to them and make them work. Whereas now they are attempting to build these robots in which they have cognitive thinking that of the human being. So what differs, makes us different from that of a machine is that our cognitive thinking and the way in which we take decisions is what makes us different from the machines. So what do we exactly mean by cognitive thinking? Is that, let us say we have a scenario in which there is our emotions play a role in our decisions. So in which a scenario in which there is a patient who is to be admitted and performed an operation, and that patient's father is nothing but the doctor who is going to operate on the patient. So the doctor as a human being will have emotions, and his emotions will play a huge role, and his cognitive thinking and his actions will entirely depend on the factor that he is afraid for his daughter. For his own fears and his emotions will come into play. Whereas if you bring a robot into that place, it can erase, or not exactly erase, it can think over those emotions, think in a cognitive fashion, and perform the operation with which, so that any other parameters will not come and affect that operation. So our main goal is to achieve that robot intelligence and knowledge in which they have humans cognitive thinking, but the emotions are controlled in a controlled manner, so that the best outcome or the result which we need to obtain is achieved. That is what the research for robotics is going on now. And in the future, this is an hypothetical say in which we can tell the robots overpowering humans and taking complete control of us. We haven't achieved the cognitive thinking of robots, so this concept remains hypothetical to us, in which the robots overpower us. Maybe if we achieve the cognitive thinking, it is possible for the robots to conquer or overcome us. It can be told with determination only after we achieve this cognitive thinking in robots. So next is vision. So what vision covers is that in places where you need image recognition. So for example, let us have a traffic light camera in which if you exceed the speed limit, the camera automatically captures your license plate and it's conveyed to the control room. So this is one little application of image recognition, where the AI should automatically recognize that speed limit has been overcome, and then capture the image of that particular vehicle which has exceeded the speed limit, and then transfer it to the control room. So this is one example of how we use image recognition, and there is one another example of image recognition in the later part of this presentation. Let us see it in then. So these are all the classifications of AI, and the major classification which we focus on today is machine learning. So machine learning, as I said earlier, is nothing but you teach the machine to learn the data, analyze the pattern, and predict the future outcome. So this is one major part of AI, where the data is analyzed and data is analyzed and the machine is trained. And with this, cognitive thinking and decision making is done. So let us now give reasons to why ML is a part of AI. First thing is that the need of data. There is large amount of data present, and we need to process this data. A human being sitting and processing this data is highly unlikely and highly, time consuming, and a process in which errors can come into play. Whereas if we train a machine to analyze this large amount of data, we can uncover patterns in the data and see how the price is being varied, or how the data moves, how there is an hike or low, what feature causes this data to behave in such a manner. All of these patterns and the large amount of data, like we'll have to analyze this for the entire data. So how this data affects the result, or how it is varying, all these things we can train a machine to understand and uncover the pattern using machine learning. So this is why we need machine learning. There is huge amount of data. We need to process the data, uncover the patterns in the data, and then we'll have to use that data for predicting future outcomes. That is why we go for ML. The second point is that in machine learning covers this aspect. You can take data, analyze, and use it for predicting future outcomes. But in the part where you need to have a cognitive thinking, in which you need to take decisions like a human being, is achieved by AI. So AI needs, an AI system needs to have cognitive thinking. And for that, it needs to first analyze what the data is. So analysis of the data part is done by ML. Your actions and executing the actions with the highest priority. Thinking like a human being is what we call as a cognitive thinking. And the third point is that decision making. Once we analyze the data using ML and make the AI system to think like a human being, the next part is to take a decision with all these data and the cognitive thinking. So with this decision making, the possible outcome with which we should expect our system to work is that it should give an optimized result to us, and if there are several results, it should give us the higher benefit of all those results. So this decision making should also be covered by that AI. So AI should not only think and analyze what is good and what is not good, it should also take a decision and execute it. So this is why this is in general the whole of AI, and this is how ML is a part of AI. How ML helps us to achieve AI is that in this data processing and analyzing part, ML helps us to do this. This is why ML is a part of AI. Moving on to the applications of machine learning in AI. The first application which we see here is an agricultural field. Artificial intelligence is being used. How it is used is that, say there are the farmer has 1 acre of land. Let us take for an example. If in general times, what he does is that he employs human labor to plow the field, to see if there are any pests attacking the crops, to see if there is any drought, and supply water to that particular part of the field, and then harvest it. So this is the process. This is the part in which the human labor is essential. So how we can overcome that is that we can take that particular field, say 1 acre of field, and divide it into 10 parts. And for each part, we can keep a soil moisture sensor where the sensor will measure the moisture content in the soil. For example, if tomato crop requires 60% of moisture, this is just an example, I'm not quoting statistics. So if it requires 60%, we can measure with the soil moisture sensor how much moisture is present in the soil. If it is below 60, then we can code in the machine to automatically switch on the motor And we can keep on measuring the soil moisture, and when it reaches 60%, we can switch off the motor. So this is how human labor is avoided in the places where the crop needs to be watered. And the next most important thing is that we should see if the crop is attacked by pests, or if there is any other growth deformity in the crop. So what we do is that we place cameras in these 10 parts of the field, and these camera constantly captures images of the leaves of the plants. So we already trained the system using machine learning. We give pictures of the leaf that is in normal condition, and what the system does is that it will take pictures of the leaf that are attacked by pests or by any other deformity, compare them, and send. It will identify if there is any pest attack. It will identify this is one problem in this leaf, and this data is automatically sent to the farmer. So in this part of your field, in this plant, this particular crop is infected. So there is one another solution for this. Another solution is that it can automatically spray pesticide to that particular plant or the crop in that field, and it can monitor for 1 day or so. Again, if the pest is not withering off, or if the problem still persists, the farmer can be asked to handle the operation immediately. He can either remove the plant, or he can use some other pesticide and see. It will be safe to remove the plant and save other crops. So this is how in pest control and pest identification, ML can be used in AI, so that the farmer, he need not monitor the field 24/7. He need not come into field daily to check the status. He can stay at home, and he can be given alerts using a message or an alarm telling there is certain problem you should look after into the field, and so that only when the problem occurs, he is required in the field. This is how artificial intelligence using ML reduces human efforts and saves and increases the yield of the crops. This is one small example in which the drones are used, the quadcopters are used to spray pests to the field, and then this is the intuitive screen of the farmer, in which he's been informed about the pH level, moisture level, temperature, and the crops. All those details are given to him, so that he can know what the environment is in his fields. So the next major application of AI using ML is in medical fields. So this is Stratius is a robotic cloud laboratory. What it does is that it automatically performs tests. There are certain tests which are required to develop a cure or develop a drug for a certain disease. So there are several tests that need to be performed, so that we can identify if this particular combination of the drug is working for the disease or not. So the Stratius, initially what we do is that we need human labor to test on the several drugs that are we have come forth with, and then produce an result. Instead, the Stratius is entirely automated, meaning you just need to give a set of instructions to the Stratius and close. And what it will do is that it will automatically perform all those tasks with the compound with which you have developed, and it will come and give you the results via an email or an alert. So what all can be said advantages in this field is that this Stratius is entirely automated, and this Stratius will avoid any error that will come in the form of human beings who test the samples. Their DNA can fall into the samples, or there can be some other mishap or something that happens, so that that sample is spoiled, and we need to start the process again from the beginning. Instead, if this is entirely automated and no human intervention is needed, the results will come out quicker, and also the results will be 100% accurate. We can see how the the drug is reacting to that particular disease, and from that we can analyze and get our data. In this Stratius, there are about 23 units, 23 boxes. We can see like these rectangular boxes over here, right? These are called as units. So there are, as of now, there are about 23 units in this Stratios, and one unit is capable of doing 1,90,000 experiments at a time, per day. So with this huge amount of calculation data, huge amount of data processing in the medical field and automation, we can use this to develop cures for diseases that are of major concern as of today. And then it is less time consuming than that of the human intervention, which is the traditional method which we follow. So this Stratios is nothing but an automated laboratory which gives 100% accurate results. And not only that, one unit can perform 1,90,000 tests per day. There are 23 units. So imagine the amount of processing that takes place in this Stratios, and imagine how different combinations of drugs can be implemented to find the cure way fast, sooner than that of the traditional method. So this is how AI helps us in medical fields to automate and speeden up the process of finding a cure. Next is artificial intelligence and entertainment. This is one common feature everyone has used. Depending on what ML does here is that you'll have a watch list. For example, say if you are preferring thriller genre, what happens is that Netflix or YouTube, it will take your preference into account and store it, so that in case if a new movie or a new series is released, which is a thriller based one, it will suggest you that particular series, telling you, see, you have already watched this, based on this I'm suggesting you this. Also, Netflix is also capable of suggesting you series or movies that are popular in your community, in your country, or in your state, or in your district. The movies or series that are popular, it will suggest you. This is possible because all of our accounts are linked, and for example, say if there is Avengers movie released, it will be suggested to like almost the entire global population. But if there is an Indian movie released, for example, let us take Bahubali, the Indian people will be suggested of that Bahubali, saying your neighbors have watched this, so you may like this. It is not you should watch and like it 100%. No, it is just giving you a suggestion. So this is how ML algorithms are used to analyze data of that of your neighbors and that of your own preferences, and come up with new technologies or new suggestions, so that you are tempted, or you want to watch that new movie, and that and so on and so forth, they increase their number of watches. So this is how ML is used in entertainment. So next major technology development or improvement using ML is using Tesla and SpaceX. So we'd have known Elon Musk as a CEO of Tesla and SpaceX. So Tesla is nothing but they develop electric vehicles. Autonomous electric vehicle is developed using Tesla, and the SpaceX is a private program in which first they wanted to collaborate with NASA, and they wanted to launch rockets. Their main aim is to colonize Mars, and in which the NASA refused, telling no, private organizations, they cannot play a major role in space adventures or missions. So you please, you have to stay out of this. But SpaceX, what they did is that they continuously for 3 or so years, they worked and developed a rocket which was reusable. And with this, after launching this reusable rocket, which is Falcon 9, the NASA again came back to SpaceX and signed an agreement with them. So after these are the two major developments or improvements in our day-to-day life using machine learning. Let us quickly see a video which demonstrates that. Let us first see how a Tesla car video looks like, in a sense, how it's an autonomous electric vehicle. The thing is that it is a driverless vehicle. We need not command the vehicle to like go over there, take a left turn, right turn, so slow your speed. No, it automatically learns its environment, and after learning that environment, it adjusts its speed or takes a right or left turn depending on its destination. So we'll see how the car has to do some process for achieving this. So let us see how this car processes this information. So this is the view of a Tesla car, in which this is how the speed, the time, and how the environment is, all these data is being displayed in here. This is simply how the Tesla car views its environment and acts accordingly. So the car in front of it is marked in green, and its speed limit is marked over here, and the signs in the side of the roads, say for example stop is over here, it is identified as stop. So the signs on the side of the road, the speed, the car which moves in front of you, its speed, all of it is being analyzed in here. So as it slows, our car slows, it checks left and right, and then it moves. So while turning, it slows down, takes a right turn, and all of the cars at the sidewalk are being monitored. It will stop over here because a car is passing by, and then it will take a left turn, and all the cars in the sidewalk are given in this rectangular box, if you can see over here. So the cars at the sidewalk are also monitored so that it shouldn't park in spaces which are already occupied, and it should avoid collision. It is for one main reason these cars are being monitored, and each and everything in the environment in which it is driving is monitored. And finally, it comes to rest in its destination. So this is how an autonomous driverless car vehicles processing looks like. It will see what are all its possible scenarios of environment, and then it will take decisions based on them. The speed, the environment, the signs which are displayed on the road, move forward, move in front of them, or cars which crosses the vehicle, all of them are monitored, and then only decisions are taken. This is how the interior of a Tesla car works. So let us now move on to the SpaceX or the Falcon 9 reusable rocket. Before moving into that, let me tell you one thing. Rockets in earlier stages were how they were used is like, once a satellite is being launched into the space, to launch a satellite into the space, we use a rocket. So once the satellite is launched into the space, the rocket which was used to launch the satellite will either fall into a sea or land somewhere safe, so that that particular rocket is not we cannot use it again. It is like it's once only usable. So after this was a huge part in which we'll have to spend lots of money for developing this rocket again and again. We can only use it as scrap. Till now, we can only use those rockets as scrap and then build another new rocket so that another satellite should be launched. So the cost for launching these satellites using these rockets are very high. What SpaceX did is that they developed a reusable two-stage rocket design, which is named as Falcon 9. So this rocket, after it launches the satellite into space, will come and settle into a predefined or preset destination or location. So if we are given a location pod, this rocket will come and land over there. With this, we can use these rockets in the future to launch other satellites. So this is one major breakthrough which a private organization achieved, that is SpaceX. And NASA, after achieving this, they signed with this SpaceX for future missions. Let us now see how the Falcon 9 works. So this is the Falcon 9 rocket, which takes the satellite into space. It's launched. This is a trial, run. One second. So I'm playing it from the beginning. Rocket is launched into the space. And then after launching the satellite, the rocket detaches itself. And there is a location given in the rocket, given to the rocket where it should come and land. You can see that the rocket returns to its predefined or predetermined location. And we can reuse this rocket for further satellite launches. With this, we can save huge amounts of money and also the R&D required for developing these rockets in the future. So this is one major achievement of SpaceX and Tesla. Both of these were possible because of machine learning algorithms. So let me quickly show you a machine learning algorithm that is coded using Python. The algorithm is linear regression. Okay, so this is the code for the algorithm. So let me quickly tell you what linear regression is. So linear regression is nothing but you have a data which varies linearly. Linearly in the sense, if your input increases, the output also increases. And if it decreases, it decreases. Or if your input increases, your output decreases. Vice versa. But it is linear. It is in a linear fashion, meaning it will only increase throughout or it will only decrease throughout. There is not going to be any change in it. So this is one such data in which we have the input along this x-axis and the output along y-axis. So this is how a Python code works. This is, we saw matplotlib libraries that are used to visualize data. Using this library only, we have displayed this data over here. And these are all other libraries which are required to perform the linear regression and machine learning algorithm. So we are importing all those. This is nothing but your header file inclusion in C program. We're just importing the required libraries using this using these functions. So we'll run it. And now we have, once it completes running, we will see that we have imported the required libraries. So next, what we are doing is that instead of giving it, so the run has completed and the libraries are included. So what we are doing here is that we are, generating a data. Instead of taking data from some database, I've just generated this data. We'll ignore it for now. This is totally not required. So using this plot scatter, which is nothing but matplotlib pyplot library, I've just plotted the generated data. So you can see that this data varies linearly. So as the input increases, the output increases. That is what we mean by linear data variation. So we have this data. What linear regression does is that it takes this data and it develops a sort of boundary or a line which will cover this data, meaning with that line we can predict future values. So that is what linear regression does. This is how this line is made to cover the data paths, and with this is the part in which we use the linear regression algorithm. So we need not code for the entire regression algorithm. We can just give linear regression. We can like download or use this, import this function from sklearn, which we would have used it over here, and then we can use this linear regression algorithm to predict the data which we have given over here. This is data we have given, and we can use this linear regression algorithm to develop a boundary or a line with which we can predict the future values. So for this data set, after applying linear regression algorithm and plotting, this is linear regression algorithm application. This is the prediction status given over here, prediction statements given, and we are just plotting it over here in these two lines of code. So after we'll run the data set, we are getting the plot, and then we are running the linear regression algorithm, and we are getting the linearly regressed data. So from this, our main aim is to train our model to understand the variation in data and predict the future outcome. So to predict, say for example, my model has inputs only for like it doesn't have input for 8. So I'll have to predict how, if I give an input, my output is going to vary. So now if I give my model predict of 8, the output I get is going to be 20.7, somewhere over here. So using this model, I can predict for future values. I can also predict it for some other value which is not in the graph. Let us say 6. So for 6, we're getting 16.8, which is roundabout over here. So this is how use. And then all of these statements are coded in Python. I hope you have understood you have caught what this example means. So now if you have any queries, please post in the chat box. If you have any queries, please post in the chat box. That I'll be able to look into that and clear yours.
Dear students, you can raise your questions in the chat window. Ma'am? Kanaga, ma'am? Hello, ma'am?
Hello.
Yes, sir. Yes, sir. Okay, sir. You can proceed, sir.
Okay. இப்போ ஓப்பன் சோர்ஸ் ஸ்டாண்டர்ட் மிஷின் லேர்னிங் பிளாட்ஃபார்ம் வந்து கேகிள் இருக்கு. ஸோ கேகிள்ன்றது என்னன்னா, இப்போ ரீசெண்டாக COVID-19 கிளாஸே போயிட்டு இருக்குதுல்ல. ஸோ அதில் வந்து நம்பர்ஸ் ஆஃப் டேட்டாஸ் வந்து நிறைய இன்ஸ்டியூட், நிறைய ரிசர்ச் லேப்லாம் கலெக்ட் பண்ணியிருப்பாங்க. ஸோ இந்த நேரத்தில் மிஷின் லேர்னிங் அதிகமாக தேவைப்படுறதுனால அந்த டேட்டாஸ் எல்லாத்தையுமே அந்த வெப்சைட்ஸில் போஸ்ட் பண்ணுவாங்க. ஸோ எந்த லெவலுக்கு அந்த வெப்சைட்ஸ் எல்லாம் தேவைப்படுதுன்னா, இப்போ எனக்கு வந்து அந்த ஆர்என்ஏ டிஎன்ஏன்ற 2 வைரஸோட டேட்டாஸ் தான் கொடுத்துருப்பாங்க. ஸோ அதை வந்து நம்ம ரொபோட்டிக்ஸ் லேபோட அந்த எக்ஸாம்பிள்ஸ் பார்த்தோம்ல, ஸோ அதே மாதிரி ஃபர்ஸ்ட் சிமுலேஷன் பண்ணி பார்த்துட்டு அதுலேருந்து வர டேட்டாஸ் அதில் போஸ்ட் ஒரு ஓப்பன் சோர்ஸ் பிளாட்ஃபார்ம். அதே மாதிரி அனகோண்டாவும் ஒரு ஓப்பன் சோர்ஸ் பிளாட்ஃபார்ம். அப்புறம் ஜூபிட்டர் லேப், இந்த மாதிரி நிறைய ஓப்பன் சோர்ஸ் பிளாட்ஃபார்ம் இருக்கு, நிறைய கம்யூனிட்டிஸ் இருக்கு. ஸோ அதுலனா போய் ஜாயின் பண்ணி நீங்க ஃப்ரீயாவே லேர்ன் பண்றதும் செய்யலாம். சம்டைம்ஸ் உங்களுக்கு டேட்டாஸ் ஏதாவது தேவைப்பட்டுச்சுன்னா கூட அதுல இருந்து எடுத்துக்கலாம். ஓகே, எனி மோர் கொஸ்டின்ஸ்?
Sir, Hari Babu have asked some questions, sir, previous to that question. Machine learning platforms using. Hello, Nandakumar sir. Hello, ma'am. Kanaga ma'am.
Yes, ma'am. Yes, ma'am. I'm just looking in.
Yeah, okay.
Okay, for ML we have other platforms which are TensorFlow and Google Colabs, with which we can use those platforms to develop solutions for real-time problems using ML algorithms. So I hope that answers your question. TensorFlow and Google Colabs are all platforms with which you can use. And then, ma'am, I think Haribabu has asked only one question, ma'am. I couldn't find the other one.
Okay, ma'am. And apart from Python, is there any other platform for that you have answered, it seems?
Yes, ma'am.
Okay,
yes.
okay, ma'am. Any other questions, dear students? Ma'am, I hope they were clear with the concepts, it seems, ma'am.
It's
Google Colabs.
Flow and Google Colabs.
Okay.
Thank you, Rahul Singh.
Any other doubts, students? Yes, Bhavya has.
Okay, is R better or Python better? So this question can be answered entirely depending on the application in which you choose to work on ML. So if your data visualization is the major part of your machine learning algorithm, then you should prefer R. So data visualization is way much better in R than that of the Python. That doesn't mean Python doesn't offer data visualization. It does, but not as vivid or as clear as that of R. But whereas if you require libraries that are inbuilt for specific functions, and your application has huge amount of data, which is entirely which entirely requires processing lots of data, and then you'll have to prefer Python. So it comes down to your application. If data processing is your major goal, prefer Python. No, if data visualization is my goal, then you can prefer R. I hope that answers your question, Bhavya.
Any other questions?
Is Python implemented in the fields like automotive steering and AMR departments? So for this question, I'm not exactly sure which language is being implemented in which department. I can only tell ML is being used. The ML algorithm developed is being used, to take decisions based on the environment. Whereas if one particular language is used, if you ask me if that particular language is being used, then I don't have an answer to that. Sorry, I'm not aware if only Python is being used in the automotive steering department or not. Because it depends on the companies that develop, and it varies from R&D to R&D. Then designing purposes. I don't understand what you are trying to tell me.
Okay, thank you, Ms. Durga ma'am, for the wonderful session. And the presentation, yes, ma'am.
I'm sorry to interrupt. There is one last question.
Yeah.
Let me just quickly tell you. So for designing purposes, you don't need languages. You only need models. So there are models like waterfall model, agile model, and the pattern in which you understand your customer's requirement. And depending on the requirement or the problem statement, you develop a solution for it. And the solution needs phases like designing, planning, execution, testing, and then working out to see if you achieve the overall model. So in designing phases, you don't require languages. You only require an algorithm or the flow in which you are going to, achieve the system, in which you are going to achieve your statement. So the designing purposes may have different styles or different ways in which you can achieve the output. It does not tell you how you are, in which language you're going to achieve is not defined by the designing purposes. So I hope that answers your question.
Okay.
Thank you. Ma'am, you can please proceed.
Yeah. Thank you, Ms. Durga ma'am, for the wonderful session, and the presentation was very informative. I thank Nandakumar sir also for clarifying the doubts of the students, and participants will be able to know more information about machine learning and what Python is and how Python is used. And you explained clearly about AI and how it is used in various applications like agriculture, medical field, entertainment, etc. And also you said about the future scenarios of ML also. I thank all the participants registered for this webinar. In this occasion, a special thanks to Dr. K. Mahalakshmi ma'am, Dean KIT for organizing this webinar. And I also wish to express my gratitude to our management, principal, vice principal, deans and HODs of various departments, faculty, friends, students for supporting us. Thank you all. Thank you. We'll end this session now.
Thank you so much, ma'am. Thank you for giving us the opportunity to handle the webinar. Thank you so much.
Thank you.
Thank you.
Thank you, students. Thank you.